To do meshing using flame meshing, we first drag the flame meshing system components to the ANSYS project schematic. Then right-click and select Properties. I will change the SI unit from meter to millimeter to make it easier for me to adjust the mesh size later. We just double-click or select Edit. I choose double precision to increase the precision of the calculation later. My processor solver is set to 4. Enter flame meshing. We just import the geometry directly. Click Import Geometry. Geometry imported successfully. Now I will make local meshing. This local meshing allows us to create different mesh sizes in certain parts of the geometry. The body of influence type allows us to create different mesh sizes, which are usually smaller, with object covering a specific area of the geometry, which I previously defined as the body of influence. I set 5 mm in this area. Next, face sizing. Near wall flows usually form a boundary layer or, in some cases, form a flow separation. Therefore, a smaller mesh size in this area is important. I set the spatial face sizing for the tetrapod walls to 2 mm, smaller than the body of influence. Click Add Local Sizing, then I immediately went to the next feature, namely Create Surface Mesh. In this feature, we can set the minimum and maximum surface mesh size. It is necessary that in complex part, the mesh size must be smaller so that the results are desirable. Click to start creating the surface mesh. Next, describe geometry. Click Describe Geometry. Go to the Update Boundary section. If it doesn't fit, you can adjust it yourself. Now I can add a boundary layer in curtain sections. But of course, this addition will increase the number of meshes and the calculation will take longer. My advice is to use only the important parts. The addition of this layer can improve the accuracy of calculations, especially in parts where the flow forms a boundary layer. I set it for the tetrapod wall only. We can see how adding this boundary layer mesh allows us to create a smaller mesh near the wall. Lastly, create volume mesh. With this feature, we create a mesh that fills the space completely. The polyhexagon meshing method allows us to create a mesh in mixed shapes between polyhedral and hexahedral. I set the max cell length to 10 mm. Then click Create Volume Mesh. Wait, because this process will take a while. Be patient. The mesh has been successfully created. We can check the quality of the mesh before doing the simulation. A good quality mesh will allow the simulation to work more accurately and, in some cases, more efficiently. The minimum value of the orthogonal quality is considered good because it's more than 0.1. You can try other quality parameters. Good luck!